Hi students, this is Albin here. In this video, we can study determination of specific charge of electron by using Thomson experiment. Determination of specific charge of electron by using Thomson experiment. So this is the introduction part. First of all, what is mean by specific charge of electron? Define specific charge of electron. Then after principle of this experiment, then there is experimental arrangement, that is he did one experiment. So what are the requirements needed? What are the arrangement of J.J. Thomson experiment? Then how to find the determination of velocity? Then how to find the determination of the value of specific charge of electron by using Thomson experiment. In this video, define specific charge of electron. See, there is E by M. So that specific charge is defined as charge per unit mass. E is a charge of electron, M is a mass of a particle. So the specific charge of electron is defined as charge per unit mass of the particle. Charge per unit mass of the particle. Principle of specific charge of an electron by using Thomson experiment. See, actually the cathode rays or travels in a straight line. So this cathode rays are travel in a straight line. Already know the one property. This is travel in a straight line. But in the presence of electric and magnetic fields, so let us consider here on electric field creating, that is one positive one plate. This is a negative plate. Generally, you know, these rays is a electron beam that is a negatively charged, already we know. So when this ray is passing near to this plate, automatically it deflected like that. Suppose this one electron is here, means this electron is accelerated, it's moving at come this place. This electron is deflecting and going this path. So the principle of the specific charge of electron, this cathode rays are deflected both electric and magnetic fields. The principle is cathode rays are deflected by electric and magnetic fields. Here, by the variation of electric field and magnetic field also, we can find the specific charge of electron. So suppose changing this metal plate, this is also deflecting this place also, depending upon this metal plate. So by the variation of this electric and magnetic field, we can also find the specific charge of electron or cathode rays. The specific charge of electron, the unit is, that is E by M, that is specific charge per unit mass. Charge already you know, that is coulomb. The unit of E by M is charge coulomb, mass is kilogram, that is C by kg, that is coulomb kg power minus 1. So the principle of this experiment is the cathode rays are deflected by electric and magnetic fields. The experimental setup, it consists of highly evacuated discharge tube. So this is one highly evacuated discharge tube. See, actually this experiment is consists of two parts. The diagram is splitting into two parts. This is the first part. So this is the one part of discharge tube. So this side, the left hand side, is connecting one battery. It consists of highly evacuated discharge tube. This is the one part of discharge tube. See, inside this discharge tube, it consists of one cathode and one anode. This cathode and anode is connecting high voltage battery. This cathode and anodes are connecting high voltage battery. Dear students, already we know this cathode rays are producing by a discharge between this cathode to anode. This only the cathode rays are producing. Dear students, see, this is the another part of the discharge tube. This is the another part of this cathode ray discharge tube. Here there is a end is not there, up to here to there, up to this much one part. This gap is not there. This is the second part of discharge tube, now only fully completed. Now this producing cathode rays are accelerated towards to the anode. This is cathode, this is anode. Then this anode having a narrow pinhole. So this is a one hole having, this is not a closed, this is open only. So this anode having one small narrow pinhole. So the producing cathode rays, I mean this electron beam. So this electron beam comes out and reach the other end of the discharge tube. I repeat again. This is the one part. This is the another part. Here producing cathode rays in between cathode to anode by varying the potential difference between the cathode and anode. Already we know producing discharge tube. Just refer that one. See here, in anode having one small narrow pinhole. So the producing cathode rays, this cathode ray is reach the other end of the discharge tube. Dear students, listen very carefully. The producing cathode rays, with the help of this narrow hole, this cathode rays passes and reaching the other end of the discharge tube. Now this cathode ray is passing through presence of electric and magnetic field. So just think it, up to this much there is no electric field and magnetic fields are there. Now producing cathode ray after, suppose inside presence of electric field E and B is there means. So first of all, the symbol of electric field is E. The symbol of magnetic field I will discuss about that later. That is because of this is third lesson. Here using two more formula also. Here in producing electric field formula, the force due to electric field is F equal to QE. The charge of electron E means EE instead of Q replacing E. But in the same way, the force due to magnetic field is F equal to BQV. Actually, you are confused because of this topic. Till now, there is not taughting because of this is third lesson. So I will teach later. So F equal to BQV. So instead of charge of electron E means that is F equal to BEV. So don't confuse. So Dear students, see now this cathode rays first of all passing through presence of only electric field. So this discharge tube containing parallel metal plates. So see here on metal plate, here on metal plate, parallel metal plate, one is taken as positive, this is taken as negative. So these two plates are is deflecting plates. These two plate is called deflecting plates. And also these deflecting plates are maintaining high voltage. So initially only considering the presence of electric field, so one taken as one positive parallel plate, then the second one is negative plate. These two plates are deflecting plates. Dear students, the presence of electric field is over. Now it is also this field is perpendicular to the maintaining magnetic field, that is B. That is correct in the electric field perpendicular at taken on south pole, this is north pole, don't confuse, that is this electric field in the magnetic field, that is south pole and north pole is like a perpendicular. So this like will come, this is actually electric field, this is producing magnetic field. So this electric field is perpendicular to the maintaining on magnetic field. So the symbol of magnetic field is B, the symbol of electric field is taken as E. Dear students, the arrangement last part, the end of the discharge tube connect one fluorescent screen. So this last end fluorescent coating, that is made up of zinc sulfide coating. Zinc sulfide coating. That means when the cathode rays hit to the fluorescent screen, that time the screen aqueous bright, that is bright will glow. That means எப்போ இந்த cathode rays இந்த fluorescent ஸ்க்ரீனில் வந்து ஹிட் படும்போது ஒரு லைட் சின்ன ஒரு மினி பூச்சி மாதிரி லைட்டாக அந்த இடம் மின்னும் ஒளிடும். This produce like a scintillation. This produce scintillation. Already you know one property. This cathode rays or negative beam of electrons produce fluorescence. So this screen is made up of, that is fluorescent screen made up of zinc sulfide. So when the cathode rays is hit to this fluorescent screen, that time the screen bright will glow. This produce scintillation. Listen very carefully. Up to this much the experimental setup arrangement is over. It consists of two tube. This is a one part tube, this is a second part tube. So inside cathode and anode is there. This cathode and anode is connected on high battery. Then already you know the principle. This cathode rays is deflecting both electric and magnetic field. Then when it deflecting is occur means the presence of electric and magnetic field. So the variation is there, that is variation of, that is presence of this electric and magnetic field is there means only this deflection is occur, otherwise is not occur. Otherwise this cathode is travel in a straight line and it reach to this screen, that time scintillation is occur. So I will send the next video how to find the determination of velocity and how to find the determination of specific charge. Listen very carefully. Determination of velocity of cathode ray, that is determination of velocity. See, this is the cathode rays, this is the cathode ray, This cathode ray, already you know, negative, that is, this cathode ray is made up of electrons, just as considering one electron. Then this is the deflecting plate. This is a positive deflecting plate. This is the negative deflecting plate. So this is positive, this is negative. So one is positive, the other one is negative. So you know this electric field direction is positive to negative. So the producing electric field is like that. Positive, negative, this arrow mark is like that. So this is the electric field direction E. Suppose one electron is placed here and this electron is travel the near of the, already you know, this is a deflecting plates. So this electron will accelerate and come near to this deflecting plate. Due to this electric field, this electron acts one force. That force is acting upward direction. So like that. Listen very carefully. This force is acting upward direction. See, due to this electric field, this electrons acting one force. This force acting like an upward direction, and it denote F suffix E. That is F suffix E. That is force due to electric field. See, force due to electric field. Then இதுக்கு perpendicular, already explained this part, இதுக்கு perpendicular placed one magnetic field. So this is south pole, this is a north pole. So this is like a perpendicular. In the electric field இது perpendicular. So this magnetic field direction is acting, that is north to south. So the direction is downwards. Listen very carefully. This part is will teach the third lesson. So this south pole, north pole, the magnetic field direction is acting north to south. So due to this magnetic field, this electrons acting one force, that force is acting downward direction, and this downward force is named, that is denoted as F suffix B. That is force due to magnetic field. This is force due to electric field. Due to electric field, the force is acting the electron in upward direction. Due to magnetic field, the force is acting electron in downward direction. Dear students, determination of velocity of cathode rays. First of all, just fix the electric field. Only the magnetic field only adjusting. During one time, this cathode ray strike the original position, that is not deflecting. It goes to the directly hit to this fluorescent screen. That time there is no deflection is occur. That is the magnitude of the force creating electric field is equal to the magnitude of the force creating due to magnetic field. Listen very, very carefully. During one time, the magnitude of electric force is balancing the magnitude of due to the magnetic field. See, Fe is equal to Fb. That time this is like an balanced. See, very, very important. When E and B are balanced, that time the magnitude of electric field producing the force that is equal to the magnitude of magnetic field producing that force are equal. That is Fe is equal to Fb. That time there is no deflection is occur. This cathode ray hit directly. That is there is no deflection is occur. Is going straight. So this original position is taken as O. There is no deviation is there. So this is very, very important. The force creating, that is force due to electric field. Force due to electric field, that is Fe is equal to, at the first lesson you know F equal, that is F equal to Q by E, that is E F equal to QE. Instead of charge of electron QE, that is F equal to EE. So here EE will come, equation 1. Then force due to magnetic field, that is FB is equal to, that is P QV will come. Instead of charge of electron, that is Q replacing E. This part we'll discuss about later, that is third lesson. So don't confuse. Now these two are balanced, that is Fe is equal to Fb, that is EE is equal to BEV. EE are cancel. Our aim is to find the determination of velocity. So velocity V is equal to E by B. Velocity V is equal to E by B. The next part is how to find the determination of specific charge of electron, that is E by M. How to find the determination of specific charge of electron. See this diagram. Due to high voltage in battery, see, due to high voltage battery, here the cathode rays are accelerated from cathode to anode. That time the potential energy of the beam of cathode is equal to the, that is converted. When the high voltage is applying, the cathode rays are accelerating. That time the total potential energy of the cathode rays are equal or converted to the kinetic energy. So potential energy is equal to the kinetic energy of electrons. So generally you know, applying potential energy, that is electron volt, EV. Then kinetic energy formula, general formula, that is half mv square. Dear students, don't get this V and this V. This is the volt, this is the velocity of the beam. So when it is equal means, by applying high voltage, this cathode rays is accelerating from cathode to anode. That time the potential energy of the beam of cathode ray is equal to the, or converting to the kinetic energy of this electron beam at the anode. So EV is equal to half mv square. So we know the value of velocity from above video. The velocity of cathode ray V is equal to E by B. Substituting, EV is equal to half m, that is E square by B square. Because of B square is there, V equal to E by B. Substituting, we get this one will come. Our aim is to find specific charge of electron E by M, that is E divided by M is equal to this. See, E by M is equal to the remaining 1 by 2. This V is goes to down, that is E square by B square. Here this E is the applying electric field, this B is the applying magnetic field, this V is the applying volt. Substituting after, we get the specific charge of electron, that is E by M is equal to 1.7 into 10 power 11, then unit of specific charge of electron E by M, that is E for coulomb, M mass, that is divided by mass, that is goes to up means kg power minus 1. This is the determination of specific charge of electron by using J.J.Thomson method. Then here two special cases having, suppose in exam time they will ask only up to this much, otherwise they will asking write the special cases, that is how to find the reflection of charge only due to uniform electric field, or otherwise how to find the reflection of charge only due to uniform magnetic field. So I will send you the next video. So this is a formula for determination of specific charge of electron. Dear students, listen very carefully. First special case, like deflection of charge only due to uniform electric field. Deflection of that cathode rays only the presence of uniform electric field. So in this time the magnetic field B is turned off, that is 0, off condition. So that is considering only presence of electric field. That time generally you know force due to electric field. What is the formula? The force due to electric field, that is Fe is equal to QE. Q nothing but the charge of electron, that is Q instead of E, we get E. According to Newton's second law, that is F equal to ma, that is F is equal to ma. Just equating, we get E is equal to ma, that is acceleration A is equal to E by m. So the acceleration of a cathode ray, that is beam of electron A, is equal to E by m. Let us consider this is the original position. Let us consider this is a discharge tube. This is a cathode rays are coming. Imagine this is like a fluorescent screen. See here, considering only the electric field, so the presence of parallel plates, positive and negative, so producing the electric field is this one direction. Here considering one charge of electron, this electron is accelerating, come here. That time listen very carefully. Now turn on for the electric field, so it is deflecting and go to the various different position. So here only the scintillation is occur. So this is one small displacement taken as y, then otherwise y dash. This is the distance between the original, that is without deviating line. This is the original position without this electric field. This cathode rays is hit to the direction is right only. So this is the original position. So distance between here to, that is O2, this point P is taken as, so O2 P distance is taken as y. So this deviation is taken as just y dash, or here whatever may be. Generally you can see y dash is directly proportional to y, or y dash is equal to, put on constant cy. This is about later. Listen very carefully. This is the L distance, so the horizontal length metal plate distance is taken as L. That means, listen very carefully, this electron beam L distance, that is here on the this L distance travel பண்ணிட்டு this y dashல வந்து deviate பண்ணிட்டு போகிறது போல. That is, these electrons accelerate and near that reach to the parallel plate after deviating because of presence of electric field is there due to electric force, that is due to electric field. This cathode ray is deviate to the another one position. So this is the original position, actual position without electric field. This is goes to right only, but here apply the principle deviating. So this distance is taken as y dash. This is the original distance, that is O2. P distance is taken as y. Then already you know when the initial velocity, when the electron starting the deviating before initial velocity is taken as u and the final velocity is taken as v. Generally you know what is the velocity, v equal to distance by time. Here distance is traveling, L, that is distance, length, that is v equal to L by t, time t is equal to L by v. To find this distance y, so you know the, or to find this distance y dash, first of all you know the equation of motion. In second equation of motion, that is s equal to ut plus half at square. Here the displacement y, first of all to find this displacement, instead of s replacing y dash is equal to initial velocity 0, so this time fully 0, half acceleration a, what is the value of a, e by m, t square, the value of t is L square by v square. Then half e L square by m into v square, velocity formula. To find determination of velocity, the formula v equal to e by b, substituting e square by b square, that is half into 1 e cancel, this b is goes to numerator, e L square, then b square divided by me. That is y dash is equal to half into e L square b square divided by me. Then you know the deflection, that is y is directly proportional to y dash. No need to, y dash is directly proportional to y, just is taken y is directly proportional to y dash, that is y is equal to, put on constant c into y dash. This is actually wrong only. So substituting the value of y dash, that is y is equal to c into y dash, that is 1 by 2 e L square by b square by me. That is, our aim is to find the determination of charge of electron. So just rearranging, here e by m is there, just taken e by m is equal to the remaining part, this 2 equal to numerator, that is reciprocal, that is 2 y e divided by the remaining c L square b square, c L square b square. Listen my dear students, first case, deflection of charge only due to uniform electric field, that time only on electric field, that is that time magnetic field is fully turned off. So first of all, to find the acceleration of the electron, that is force due to electric field is F equal to QE. According to Newton's second law, F equal to ma, equating we get A is equal to E by m. You know it is a one electron. This electron is near come to this deflecting plate. That time it is a without electric field, it is goes to straight line, but apply the principle, presence of electric field, it is deviating. So this deviation is taken as y dash. This is the total deviation, that is the original position to another one position, deviating position, the resistance is taken as Y. Here, after substituting, we get the value of E by M is equal to 2YE by CL square B square. Substituting the value of right hand side, Y the total displacement, E applying electric field, B applying magnetic field, L the horizontal distance, this distance, C that constant. After substituting, we get the value is E by M is equal to 1.7 into 10 power 11 coulomb kg power minus 1. Then second part, that is deflection of charge by using uniform magnetic field.